Hello everyone. Good morning, good afternoon, and good evening. Dear authors and invited guests, welcome to the technical session 12A. Myself Shashwat Mani Tripathi, and this session would be moderated by me. On behalf of Global Knowledge Research Foundation and GR Scholastic, it's my great pleasure to welcome you to the 10th International Conference on Smart Trends in Computing and Communication, SMARTCOM 2026, Pune, India. The 10th edition of the conference is being organized in the hybrid mode. The physical event is held on 19th Jan 2026 in Pune, India, and the virtual event is being held through Zoom from 19 to 21st January 2026. I hope you will enjoy the knowledgeable and interactive session through the day. In this session, we have 10 presentations. Each presenter will be given 10 minutes for the presentations and 2 minutes for question and answers. On 9 minutes, I will raise a gentle reminder. There is another request to all the participants that you all stay connected with us till the closing remark. If you have any query or update, then you can write it to me in a chat box. Just before we start this session, I would like to introduce you all to the chair of this session, Dr. Saroj Kumar Raut. Sir. Sir is an associate professor in the School of Computer Science and Engineering at VIT University, Andhra Pradesh. His research interests include artificial intelligence, machine learning, and wireless sensor network. He actively contributes to teaching and research, collaborates with faculty members, and he is engaged in advancing work in cutting-edge computer domain at the university. Sir, would you like to share a quick opening remark with us?
Yeah. Okay. So we will be proceed. Thank you to invite as a session chair. I'm so happy to mark the some comments and all the things to the young researchers and all the research work. Thank you. So you may start and proceed.
Sure, sir. So now I would like to start with the papers. First we have Vijendra Sahu, paper titled AI with Heart Transforming Customer Interaction Through Emotional Intelligence. Now we have Vijendra Sahu, paper titled Beyond the Stethoscope Transforming Healthcare Diagnosis Through IoT Driven Intelligence. Okay, now Johnny Rana, paper titled Chitran, Real Time Collaborative Whiteboard with Hybrid Conflict Resolution.
Yes, sir.
You may please start presenting your presentation.
Good good afternoon, sir. I am Johnny Rana. Today I will present Chitran, a real-time collaborative whiteboard designed to solve scalability and consistency issue. सर एक मिनट स्क्रीन शेयर करता हूँ. Good afternoon, sir. I am Johnny Rana. Today I will present Chitran, a real-time collaborative whiteboard designed to solve scalability and consistency issue in multi-user editing system using a hybrid OT operational transformation CRDT conflict-free replicated data types approach and Redis publisher and subscribers. प्रॉब्लम स्टेटमेंट मतलब स्केबिलिटी कंसिस्टेंसी गैप जो है मतलब कि हमारे आइडिया के बयान जो भी हम यूजर लेटेंसी एट स्केल होता है मतलब कि जैसे कि हम जब यूजर हमारे किसी भी अगर जैसे हम ले लें व्हाइट बोर्ड का एग्जांपल ले लेते हैं जैसे कि इरेजर डॉट आयो है उसमें हम जैसे कि 25 से 30 यूजर जब बढ़ते हैं तो उसकी जो लेटेंसी स्पीड है मतलब कि 200 ms से ज़्यादा बढ़ जाती है मतलब कि उसका लेटेंसी स्केल जो है बढ़ता चला जाता है टाइम टू टाइम डाटा इनकन्सिस्टेंसी हो जाती है ग्रुप अपडेट प्रॉब्लम हो जाती है अपडेट नहीं होता आर्किटेक्चरल बोटलनेक होता है रिसर्च गैप होता है और when many user work ऑन द सेम वाइट बोर्ड सिमुलेटर 3 मेजर प्रॉब्लम आती हैं। हाई लेटेंसी हो जाता है, डाटा इनकंसिस्टेंसी हो जाता है, सर्वर बोटलनेक हो जाता, व्हाइट बोर्ड स्लो डाउन हो जाता आफ्टर 20 to 30 ग्रुप पीपल जब एक साथ वर्क करते हैं उस पे। Our goal was simple but challenging. Keep latency below 200 millisecond, prevent conflict like lost update, make the system scalable using Redis publisher subscribe model, ensure secure and persistent data storage. Some tools are but do not scale like peer-to-peer whiteboard, other core features rich slow. Figma perform well but is not a general purpose whiteboard. They create a research gap. We need both scalability and correctness. High level architecture. Chitran use a three-tier architecture: front end, back end, and data layer. Handle user interaction. The back end manage synchronization logic, and the data layer ensure persistence and message broadcasting. Hybrid synchronization. CRDT and OT operational transformation conflict free replicated data type. Use hybrid conflict resolution model OT plus CRDT with Redis publisher subscriber for a real-time scalability conflict free replicated data type. Hybrid OT CRT for parallel independent action. Drawing, moving, shaping, deleting object, cursor move. Operational transformation for order, dependent action, undo, redo, layer recording, grouping, object version restore. Uh, If the user move shape simultaneously, CRTT handle it, but if a user purges undo, it must follow strict order. So OT is used, the system decide automatically. Bottleneck problem: WebSocket server required a direct connection between all users. If one server fail to get overloaded, entire collaboration season break. It's used the solution Redis publisher subscriber model. Publisher send the message to the channel, subscription listen to the channel and receive the message in real time. No storage of a message if subscriber is offline. Publisher send message channel named message stream, subscriber receive message real time, live dashboard, chat system, event broadcasting. When the system run on multiple server, user may be connected to different. Any update from user is instantly broadcast to all the server. All connected client stay synchronized. Data persistent post SQL DBMS stored canvas state user permission and version history. This enable this enable restore, undo and long-term collaborative. Feature enhanced real-time calibration, infinite canvas, AI safe recognition, live cursor tracking. These features improve usability of these systems. Functional scope system use cases testing with the 20 concurrent users so on average average latency is 154 ms with 95 operational below 180 ms latency and zero data inconsistency. We use JSON-based authentication and secure WebSocket feature work included end-to-end encryption. Future roadmap phase enhancement plan. Next, we plan to test 50 to 75 user add offline mode and deploy edge-based Redis clusters. Conclusion. Chitran successfully balanced speed and consistency using a hybrid OT CRTT model. It achieved sub latency is 200 ms latency with zero conflict and is ready for enterprise scale deployment. Thank you, sir.
Thank you for the
Okay.
presentation. Sir, do you have any questions?
Yeah. So, how your model will be provided the security and persistency from authentication point of views? Your model, how it is provide some security and persistency?
Security and persistency. Sir, एक minute.
Because you are using some distributed model.
Yes, sir.
How that model provides some security? How you secure your data? How you authenticate your data?
सर JWT टोकन्स जो टोकन्स होते हैं मतलब कि डिजिटली टोकन्स होते हैं जो बनाते हैं उन्हें यूजर को प्रोवाइड करेंगे.
So you are using different architecture. So one of the architecture is three-tier architecture. Can you explain your model in three-tier architecture?
यस सर. थ्री थ्री टायर आर्किटेक्चर मतलब कि फ्रंट एंड जिसमें मतलब कि रिएक्ट जेएस और कैनवास का यूज कर रहे हैं. बैक एंड नोड जेएस और वेब सॉकेट डॉट आईओ का. और सर एक डेटा लेयर होगी जो पोर्ट्स एसक्यूएल डेटाबेस होगा विद मतलब कि पब्लिशर और सब्सक्राइबर मॉडल का मतलब कि वो भी ऐड करेगा मतलब उसकी एंट्री वगैरह सारी चीज रखेगा.
What is the limitation of your model?
सर लिमिटेशन ये है कि सर अभी हमने जो यूज करा है इसे मतलब कि 50 to 60 यूजर ही टेस्टिंग कर पाए. इससे ऊपर अभी टेस्टिंग नहीं कर पाए.
Thank you. Anyone having question, you may ask.
नो सर. थैंक यू सर.
Oh,
So next we have Vijendra, paper title Circular Economy and Green Finance, Exploring Financial Model for a Zero Waste Future. Next we have Tanvi, paper title Demystifying My Misconception, Charting Student Math Misconception Using Deep Learning.
Yes, sir, just a second.
You may please start presenting your screen.
Am I visible and audible?
Yes.
Good morning, respected judges, professors, and all participants. Today, I'll be presenting our research paper titled Demystifying Misconceptions charting student math misconceptions. I'm Tanvi Mehta, and I'll be walking you through our research work. The primary objective of our research is to design a generalizable machine learning driven NLP framework capable of automatically identifying subtle mathematical misconceptions from students' written explanations. Students often provide reasoning in natural language, and these explanations contain hidden misconceptions that are difficult to detect manually at scale. Students develop a range of misconceptions in mathematics, sometimes because they are unable to apply prior knowledge to new content, and sometimes because they are trying to make use of the new information but misunderstand it. Our goal is to automate this detection process, enabling accurate and consistent identification of misconceptions across diverse mathematical problems and learning contexts. In mathematics education, misconceptions are not random mistakes, but systematic incorrect patterns of thinking. Many students apply prior knowledge incorrectly, and so we have figured out what is the problem in the existing methodology. There are various large language models that have zero or few short prompting. Prompt LLMs to analyze explanations against misconception catalogs via zero short classification or embedding cosine similarity. These fail from hallucination or math specific nuances, poor generalization across problem types. There are pre-trained language models that are already existing in the market. They are generic and do not provide exact solution to whatever feedback that has been generated from the students. The third being BERT topic clustering. HDB scan clustering discards outliers and is unable to identify misconceptions according to various different feedbacks given by the student. Their explanations are not completely understood by the model and hence gives wrong results. This led us to making our own model. The architecture is given. Our methodology integrates classical machine learning with modern NLP techniques. We apply advanced text pre-processing, feature engineering, and vectorization strategies, followed by model training using optimized classifiers. Cross-validation ensures robustness, while careful hyperparameter tuning improves generalization across unseen student responses. The input processing can be done through various steps of pre-processing. The multi-scale features include TF-IDF, unigrams, bigrams, trigrams, and a unique feature selection using chi-square. The robust training is done through the five-fold light GBM classifiers that generates the final result using the MAP3 ranked category. Comparative analysis between the various models that have been that were tried by us but did not give accuracy and precision up to the maximum level included the hybrid light GBM plus transformer. It had 6.8% of accuracy, while our model has 96.8%. There were no transformer overhead real-time inference enabled. The full interpretability versus their black box embeddings did not work well. Second being the LLM ensemble, the six model voting system. Our model had crushed through their model training because of the massive multi-LLM costs, and ours had a simple deployment. The final being a multi-model fine-tuned ensemble. Ours had single model efficiency versus theirs was a 4+ model complexity. Dataset overview. We had primarily used our dataset from ED and other generated other synthetic validation sets so that we could train on multiple sets and then find the final output. For our study, we leverage a large-scale data set consisting of student responses, question text, and labeled misconceptions. Each student explanation is treated as a natural language input, and the task is framed as a multi-label ranking problem where the model predicts the top possible misconception. We evaluate performance using the MAP at 3 metric, which measures how well the top 3 predicted misconceptions match the ground truth. Results were simple that our model achieves a MAP at 3 score of 98.6%, outperforming all Kaggle baselines on datasets exceeding 1 lakh samples. Both precision and recall consistently exceed 98%, demonstrating strong reliability and stability. Even with synthetic data, we were able to get 98.36% of accuracy. These results highlight the effectiveness of our approach in accurately capturing nuanced misconceptions from natural language explanations. Technology integration, from a system perspective, our solution can be seamlessly integrated into digital learning platforms. It enables real-time feedback, supports teachers in diagnosis, and enhances personalized learning by identifying conceptual gaps early. This makes the framework highly applicable for edtech systems and intelligent tutoring platforms. Challenges and limitations. Despite the strong performance, accuracy, and precision that we had received, there are certain challenges that remain. Very short or ambiguous student responses often lack enough contextual information, which can affect prediction confidence. Additionally, inconsistent language usage and informal phrasing introduce variability in interpretation. Addressing these challenges opens directions for future work involving context-aware and transformer-based models. Our future work include expanding this to other subjects as well and in other languages as well. Thank you.
Thank you for the presentation. Sir, do you have any questions?
Yeah, okay. So you are using a very nice NLP model to picture selection and model trained. So my question is that can you explain how your picture selection process will be conducted in that process in picture selection? How it is conducted in the picture selection in your model? Can you explain?
Yes, for our model specifically, whenever there are different types of statements that are given, that could be in jumbled sentences, or it could include wrong symbols, or it could include mathematical expressions that are not required for an explanation, or when you are giving an explanation. Our model would first of all filter that out and then select what is the meaning behind the base sentence that has been formed. After that, there is a five-fold system that goes through. So after that sentence has been processed for 5 different times, the final output is then registered and it is understood and then given marks on.
Okay, you are using the light GBM model
GBM.
during the model
Yes.
during the model training. So how that light GBM model will help you?
Light GBM in general is used when you have a large amount of data set. So we plan on establishing this for the entire school. So whenever the data is given through or passed through, Light GBM will be able to process it accurately in lesser time complexity.
Comparing different data set with your model.
We did not compare different data sets. We had to generate synthetic data set because the one which we had obtained from ED and Kaggle was not enough for us to get enough understanding of what are the different types of feedbacks or explanations that students write.
So what is your accuracy for that synthetic data sets?
96.8%.
Okay, very good. Thank you.
Thank you.
So next we have Mayuri, paper titled Explainable Deep Learning Solutions for Real-Time Clinical Decision Support in Liver Transplantation.
Yes, sir.
You may please start with your presentation.
Yes. Is my screen visible?
Yes, it is.
Okay. So good afternoon, sir. Myself, Mayuri Satpute, and today I am presenting the paper title is Explainable Deep Learning Solutions for Real-Time Clinical Decision Support System. So the outline of my today's presentation, sir, introduction, then the need of the study, objectives, literature review, research methodology, data analysis, conclusion, and the references. So now the first is the introduction. So mainly the liver transport, exactly the liver transplantation. So in liver transplantation, the deceased liver is replaced with the healthy liver. That means the donor is there and the recipient is there, and we have to analyze what exactly the problem. Mainly the liver failure occurs because of the different reasons. That is acute liver failure, then the hepatitis B or alcoholic liver is there. So in that, the surgeons or the clinicians are replace the deceased liver with the healthy liver. So mainly if we use AI or explainable AI in the liver transplantation procedure, then it is very helpful for the clinician to analyze the donor recipient compatibility and the survival rates. That is the prediction outcomes. So AI is mainly used in liver transplantation to analyze large scale clinical data and predict outcomes. So basically in the liver transplantation, the data sets are too much higher. So to analyze the data, I'm going to use it here, that is explainable AI. So why explainable AI? So explainable AI will analyze why the doctor says that this compatibility is perfect or this matching is perfect. So liver transplantation process is mainly divided into two parts, that is donor recipient matching and the post survival transplant rates. But in the donor recipient matching and the post transplant survival rate. So in donor recipient matching, donor's livers get matched with the recipient liver with the different factors by using different factors, that is a blood is the main important factor in that for donor recipient matching. Then the different EHR is there, then the clinical notes are there, then the liver size is there. So these different factors are there. So AI model assesses these compatibility factors and predicts survival rates and potential complications. So if there is complication after post transplant, so this explainable AI identifies based on their current factors. So the proposed framework uses internal and external data sets for model validation. So internal and external data means they are using genomics data as well, then the clinical notes as well. For clinical notes, we are using NLP in this. So performance improvements are evaluated by benchmarking AI models against clinical decision system. So the why this explainable AI in liver transplantation. So liver transplantation is very critical procedure where accurate liver donor recipient matching and survival predictions are essential for patient outcomes. So accurate liver, our model supports accurate donor recipient matching by using this. Then existing clinical scoring systems are mainly rely on the limited parameters. So they are only focusing on the MELD score of the donor. MELD score is nothing but the model for the end stage liver disease, where the MELD score is calculated, donor's MELD score is calculated, and when based on the MELD score, the compatibility is decided. So then AI-driven models, particularly deep learning, offer enhanced prediction capabilities, but often lack in interpretability and limited their clinical adoptions. So if we use deep learning or if we use explainable AI in prediction capability, so it will be very helpful for the clinicians to accurately decide the donor recipient matching and the post-transplant survival rates. There is a need for explainable and trustworthy models that integrate clinical knowledge with the advanced algorithm to support the decision making in real time. Then the objectives are to develop an explainable deep learning based clinical decision support system. So here we are using explainable AI with the deep learning that accurately supports the clinicians' decisions. Then to improve the donor-recipient compatibility prediction. So compatibility prediction means exactly donor-recipient matching, which is pre-transplant, which is done after before your transplant. Then to predict post-transplant survival outcomes. So here we are going to detect the survival rates after the post-transplant. Then to ensure transparency, trust, and regulatory compliance. So here we are going to analyze our model with the help of different clinicians. Means we are going to visit the different hospitals and take their suggestions with, to check our models whether it is so for the survival rates or for donor recipient matching. So the literature review or the research gap. So we have analyzed different types of papers. So based on that, we have analyzed that is machine learning models improve prediction accuracy but act as a black boxes. So act as a black boxes means they are improving the prediction accuracy, but actually clinician doesn't know the doesn't uses that models. Then limited multimodal data integration in existing systems. So limited multimodal data means existing system are using only the EHR rate or only the mail score. They are not using any clinical notes or any genomics data for the donor recipient matching or for prediction post-transplant survival rates. Then poor generalizability across transplant centers. Poor generalizability means so actually clinicians are using this only method that is based on the notes and based on the they doesn't use any models for their predictions. Then the lack of real-time and interpretable clinical support tools. Then the proposed system is, so this is my current existing proposed system, that is explainable AI-based liver transplant decision support system. So in this, that is the data sources. The first part is the data sources. Then the next part is the data processing and the integration. Then third block is the XAI model architecture. Then fourth block is explainability mechanism. And the next is the clinical decision support system. So first one is the data sources. So we are collecting the data from EHR, that is electronic health records, and clinical notes are there, which are suggested by clinicians. Then imaging data means MRI scan, CT scan is there, CT scan of liver, MRI of liver. Then genomics data. So genomics, in the genomics data, HLA is the test, which is very important while donor recipient matching, human leukocyte antigen, which is used to prove the blood relations of the donor and recipient. Then the last one is the donor registry. So in donor registry, donor age is there, then blood group is there, then liver quantity. Actually, size of the liver is very important in the transplant. Then next is the data processing and the integration. So in that there are three processes: data ingestion, feature extraction, and privacy security. So data processing and integration takes the data from different data sources and it gets ingested, then different features are extracted with the privacy and the security. Then next is the XI model architecture. In that, multimodal neural network is there. So multimodal neural network combines clinical imaging as well as the genomic data. Then the next is the compatibility predictions. Actually, it predicts the donor recipient compatibility, mean donor, whether the donor is suitable for recipient or the whether recipient is suitable for donor for transplant, like liver transplant. This is done in the compatibility prediction. Then the next is the survival outcome prediction. So it estimates post transplant survival probability and the graft success. Graft success means liver success. Then the interpretability layer is there. It bridges the complex AI predictions with the human understandable explanations. So means our explainable AI model explains why this donor recipient matching is important, because as surgeons or the clinicians suggest that this donor recipients are matched for these are for liver transplant, but our XI model suggests that why this is important. It explains why this donor recipient matching is important. Then the next is the explainability mechanism. In the explainability mechanism, we are using sharp analysis, attention maps, and the rule-based insights of the XAI features of the XAI. So sharp analysis shows how each feature contributes to the prediction. How each feature means how the blood group, then the age is there, then the clinical notes of that patient, how that each feature contributes to the prediction, compatibility predictions. Then the attention maps. Attention maps highlights critical regions in imaging data influencing decisions. Then the rule-based insights are there. So rule-based insight provides logically clinical meaningful explanations with the help of this sharp attention. Next is the clinical decision support system. So clinical decision support system in the donor recipient matching, the stratification and the outcome recommendation. So in this donor recipient matching, it recommends actually with the help of these different features, with the help of these explainability features, donor recipient matching finally recommends the optimal donor recipient matches. Then risk stratification, it categorizes patient into low, medium, and high category. So based on the low, medium, high category, our model suggests that which patient needs a liver transplant, which patients needs liver transplant at the priority. Then the outcome recommendation, it suggests best clinical actions based on the predictions. Now the last is the feedback loop and the model update. So feedback loop means we are taking the feedback from clinical clinicians to support our model or to check whether our model correctly identifies or correctly predicts this donor recipient matching or the post-transplant survival rates or not. Then the next is the data quality of and the challenges of our model. So mainly
You have 1 minute to conclude your presentation.
Yes, okay, sir. So in this, we have analyzed the challenges are missing or incomplete clinical data. In the existing system, there are lots of missing and incomplete data is used. Then small and imbalanced data sets are there. Privacy and the restricted data sharing is there. So these are the data quality, data analysis for our current system. And the conclusion is the proposed system significantly enhances predictive accuracy by leveraging multimodal data and advanced deep learning models while maintaining high level of interpretability through explainable AI techniques. So these are my references. Thank you so much.
Thank you for the presentation. Sir, do you have any questions?
Yeah, okay. You are using the XAI model.
Yes, sir.
So can you explain how that XAI model for the cervical prediction that can
So
does
basically, we are using explainable AI with deep learning. So first of all, with the help of deep learning, we are extracting all the features of that liver donor and the recipient. Then our explainable AI using sharp analysis, that attention mechanism, for suggesting that if any clinician suggests that the donor recipient or this liver transplant is suitable, then our model suggests that why this is important or why this is suitable, why they both are suitable for each other. So mainly we are using for that purpose only.
so in case of the clinical decision support system, how the risk stratification can handle your model?
So in that we are using different types of, that's why we are using multimodal data. So we are using clinical notes. In that we are going to use NLP as well, then the electronic health record, then the genomics data as well. So mainly if the blood relation gets proved with the help of HLA test, then it is very easy to analyze if the that compatibility prediction is compatibility is success or not.
Okay, one more question. For the clinical support system, how it helps for the doctors?
सो मेनली सर क्या होता है ना, बेसिकली लिवर ट्रांसप्लांट में अभी क्लिनिशियंस क्या करते हैं कि और सर्जन्स क्या करते हैं कि दे टोल्ड कि दिस ट्रांसप्लांट इज डोनर बोथ आर कंपेटिबल विथ ईच अदर और नॉट. सो दे टोल्ड, बट मोस्टली क्या होता है ना, जब रूरल रीजन में हम चाहते हैं तो लोगों को भरोसा नहीं होता कि ये क्या बोल रहे हैं, कैसे बोल रहे हैं. तो सो मेनली अवर मॉडल सजेस्ट दैट व्हाई दिस donor recipient matching or why they are compatible with each other for the liver transplant. So that's why we are using explainable machine learning.
Okay, thank you. Nice presentation. Okay.
Yes, thank you, sir.
So next we have Satya Sai, paper titled Mapping Global Research Trend in E-Government Adoption and Bibliometric Analysis Using R.
Sir, I'm audible, sir?
Yes, you are audible. You may please start the presentation.
Yeah, thanks. Honorable session on the chair and co-speakers. It's a privilege for me to present this paper. I joined with my co-authors Puneet Gupta, myself, and Prakash Rao. Sir, mapping global research trends in e-government adoption. This is close to my heart, and this is my first paper on this area. Sir, e-governance adoption, sir, being from the government as a senior director, served for the entire government from government of India. We e-government, e-governance, we do e-governance, a lot of applications we deploy, and for the transparency purpose, efficiency, and citizen participation. But always there is a barriers, including the skills at the delivery point, like a MiSeva, which I designed for the.
Sir, your voice is not properly audible, so can you adjust your
Now, sir,
microphone or the?
is it now?
Your voice is not properly audible. Can you adjust the volume of the things?
1 second. How is it, sir, now?
Yeah, it is clear.
Sorry, sir. Sorry for that. So, should I start from the beginning, sir? Is it all right, sir, now? Hello?
Yeah, correct. Okay, sir, you continue.
Sir,
Sir, continue.
yeah, thank you, sir. Today, e-government adoption, that means that by the citizen or by the delivery points, it's always our intention is to enable the transparency, efficiency, and citizen participation. But the barriers like skills, infrastructure, and trust gaps are also there. Because being from the government and delivered various services in government of India, like the citizen service centers in Andhra and Telangana, especially through MiSeva, we found a lot of though government intentions are extraordinarily to deliver the services, government services through the citizen service centers, etc., or online centers. The skill set of the delivery kiosk operators or the citizen at large through a skill but not having skills like a labor license. If you want to deliver the labor license, then the procedural aspect of the domain knowledge of that is also required. That is this in that context this paper is being presented, sir. New technologies like IoT or AI, blockchain accelerates the digital governance transparency. Bibliometric helps us map productivity, influence, collaboration, and the thematic evaluation at scale. Sir, prior to bibliometric studies, seldom focus explicitly on adoption or intention to use within the government, within the e-government services. Our aim is to conduct bibliometric analysis using R software to reveal the infrastructure, collaboration, and sources, authors, and themes. Identify the core emerging topics to guide the researchers and the policymakers towards the context-driven strategies. Sir, literature review. Several previous studies employed in bibliometric methods to explore the government research fields. And recent articles have started the deployment of e-government research by examining its intellectual structures, topics, etc. for last 20 years that we have taken from the data from the 2004 to 2025. To best of our knowledge, no bibliometric study has explicitly concentrated on the adoption or use of intention to adopt the e-government services, which is noticed as missing research that present the paper to attempt to fill in. This reflects a fundamental knowledge gap, how this Scopus database has been employed to investigate pattern and insights of what the e-government adoption. Sir, research methodology that we deployed this bibliometric analysis that Arya and Google 2017 in 5 steps of design, collection, analysis, and visualization and interpretation. Employs bibliometric analysis in 5 steps, the same thing. Use biometric R package. We used the R software, sir, Biblioceny for a descriptive production and others networks. We made a query on this e-government adoption, acceptance, and intention to use it. Final data set, though we got a 720, we have the duplicates, etc. And 681 was the 681 documents are retrieved to do this analysis. Again, this research methodology. Growth, purposeful annual growth rate has increased to 6.5. Average citations documents is 34.26. Average document age is 8.74, 8.73. And the conference papers 244 comprises of 80% of the output. Intellectual depth 3,722 reference indicates the density citations backbone. So this is a pictorial representation, the statistics that we have taken from the R software. So this annual production also steadily increased. In 2004, it has come, it is very less, yearly 2012 and renewed by 2022, and it is 24, 23, 22, it is the highest kind of a thing. Minor recent dips reflects the topic saturation or refocusing rather than the declining in relevance. So sourced four outlets, sir. Leading outlets, international journals like Electronic Government Research, Electronic Government Information Quarterly. These are the 5 to 6 highest, focused on this. The Bradford zone shows a concentrated core plus broad plan tiles across IS and publication and policies. These two graphs, like most recent, most relevant sources, articles and journals, and source production over time is indicated, which is encouraging, and it is on a day to day, year to year, it is going on increasing. Others and productivity, this Divedi and Mr. Minash, I believe, and these others have a large contribution to it, and 68.7 single paper users, others at 61.9 expected, 59.9 two papers, and these are the two graphs indicates that the most relevant others and more other productive to Lotka law. So this is the representation of the countries which are having this. China is the highest volume of contribution, and next is Malaysia, Indonesia, like this. And keywords that e-government, government data processing, e-government service adoption concludes this and dominate. These are the words. So network clusters are span adoption of behavior, trust, and delivery of the policy, indicating the social economic field. So this is the pictorial representation that is the highest, the larger the size of the word that e-government dominates and government data processing next, like that it is being we can analyze, sir. The same thing, the tree map also, it is we have framed through a map. The larger the box, the e-government has 3.3, 16% indication, or the same thing which is referenced here. So conclusion, the field matured multidisciplinary and global collaborative core themes, services, data handling, trust adoption, emerging areas, cybersecurity, AI, blockchain, citizen engagement. Limit is this data set is taken from the only Scopus, sir. It is not from the, we have to take it from WOS, etc. And others languages, China, or other countries, they might have kept it in their own language or their own local journals. That is, we need to, that is the limitation, that is Scopus only we studied, which is in English. Feature that context sensitive research and indigenous platform like a Zoho, etc. we have to qualify. So these are the 24 references we have taken, sir. Thank you, sir. Thank you.
Thank you for the presentation. Sir, do you have any questions?
Yeah. Okay. For multidisciplinary research point of views, how it helps for the researchers?
Sir, actually, because the various, my understanding is, sir, there are different types of departments or multidisciplinary kind of a thing, like a rural development or medical or things that we are doing. Around 33 departments are being delivered in India through our citizen service sectors, etc. It may be a rural development, labor department, or a medical even police, sir. Recently, last 10 years, we have delivered through, even FIR is being delivered through KCS. So it is my understanding is it is an e-governance context. We are doing through different departmental services through online or through a citizen service sector. That's my understanding, sir.
Yeah. So my last question, from the Lothos law point of views, how it helps for the covering aspect?
Sir,
Because you
sorry.
have already showing that simulation works using the Lothos law. From the Lothos law aspect point of view, how it is covering that points?
So I need to check up, sir.
Yeah. In your research work, you have already using the Lothos law.
Yes.
So in simulation work, here.
This one, sir, that is
Lothos,
single paper
yeah.
others, that it is single paper others, 68.7 is expected. Now it's going on. It is it became diversified. It is going on a diversified way. So more articles are being, more subjects are being covered in the instead of single kind of a thing. It's a growing.
Okay, sir. Thank you for your nice presentation.
Thank you so much, sir. Thank you. Thanks for the opportunity.
So next we have Renuka, paper titled OptiSchedule Algorithm for Automatic Timetable Generator Nexus of Meta-heuristic Optimization Approach with Heuristic Search Technique.
Yes, sir. Good afternoon.
You may please start your presentation.
Yes, sir. I'll just share this.
Please, sir, please stop your presentation.
Sir, I'll request you to kindly allow me to share my Word file. I have a PPT also.
Yeah, please,
Some
please.
data, is there which I can show in the Word file.
Okay, please.
Yeah. So the topic is optimization, OptiSchedule algorithm for automatic timetable generator, nexus of meta-heuristic optimization approaches with heuristic search techniques. So along with me, other three authors have also contributed in this research paper. So myself, Dr. Renuka Deshmukh. I am affiliated with Dr. Vishwanath Karat, MIT World Peace University, Pune. So in this paper, we have focused on the automatic timetable generator. I'll just share my screen. Just give me that. Is my screen visible, sir?
Yes, it is visible.
Oh, okay.
Please continue.
Yes, sir. So the primary objective of this research endeavor encompass a holistic examination of OptiSchedule's capabilities. So thorough, meticulous empirical validation and extensive experimentation, this paper seeks to dissect OptiSchedule's performance metrics, meticulously evaluating its proficiency in generating high-quality timetables, optimizing efficiency, and dynamically adapting to varying scheduling paradigms. So additionally, a comparative analysis juxtaposing OptiSchedule against conventional methods serves to elucidate its distinct advantages and underscore its superiority. So furthermore, beyond theoretical exploration, this paper delves into the pragmatic implications and real-world applications of OptiSchedule. By illuminating its versatility and efficacy in addressing scheduling complexities across different sectors, this research aims to catalyze the adoption of OptiSchedule as to go-to solution for automated timetable generation. The seminal contribution of this paper pivot around the conception and refinement of OptiSchedule, which represents a pioneering endeavor at the intersection of heuristic search and meta-heuristic optimization in the realm of automated scheduling algorithms. So here we have, as you can see, we have prepared a flow chart. So this helped us to move ahead in our journey, and we could come to fruitful conclusions. So in this flowchart, homepage, then login with username and password, insert courses, add class sites, create timetable with subject slots, faculty details. If faculty available, allot the faculty to respective subject. Otherwise, if there is any empty slot, go back to the step. So this was the algorithm through which we could route our journey. So next works we have prepared and given slots in the random timetable, so day wise. And then a questionnaire was also prepared in which we actually asked the faculty few questions. A survey was also done, the faculty members in our institute. Again, in-depth literature survey was conducted using various case studies and desk research. So the results which we got through our analysis was our OptiSchedule algorithm outperforms competing models in key aspects, affirming its superiority in automatic timetable generation. So higher fitness scores. So we had highest fitness score in the graphs. We have shown this. So under higher fitness scores, our schedule consistently achieves superior fitness scores compared to various algorithms, ensuring schedules that meet diverse criteria effectively. Then OptiSchedule clash minimization. OptiSchedule excels in minimizing clashes, delivering schedules with reduced conflicts and heightened efficiency. Maximized room utilization. The optimal schedule algorithm stands out in the room utilization, maximizing resource efficiency and providing optimized schedules. The next benefit was enhanced adaptability to changes. So OptiSchedule exhibits superior adaptation speed, accommodating real-time changes without compromising schedule quality. Superior fairness in allocation. So OptiSchedule maintains a higher fairness index, ensuring equitable distribution of prime time classes and resources. Then the reliable machine learning predictions. This model integrates accurate and confident machine learning predictions, bolstering and reliability of generated schedules. Robust algorithm convergence. This was the next conclusion and finding which we came to. So OptiSchedule consistently achieves satisfactory timetables, demonstrating robust convergence throughout iterations. In summary, our OptiSchedule algorithm stands as a superior solution, offering optimized schedules that surpass competing models in key performance metrics. So I'll just scroll down to show you the data. So maximized room utilization, optimized clash minimization, superior fairness in allocation, enhanced adaptability in changes, reliable machine learning predictions, robust algorithm convergence, course table given by the user, the timetable generated, so the generated output table. So I will show you the table. So the OptiSchedule algorithm revolutionizes timetable generation by effectively addressing constraints, optimizing schedules, offering flexibility, enabling parallelism, and allowing customization to user preferences. However, despite its numerous advantages, there are some limitations to consider. For instance, while the algorithm can handle various constraints efficiently, it may struggle with highly complex scenarios or suddenly changes that require immediate adjustments. So additionally, although it strives to fulfill user preferences, there might be instances where certain constraints or preferences conflict, leading to suboptimal solutions. So furthermore, while the tool's adaptability and real-time adjustments are commendable, there could still be instances where manual intervention is necessary. especially in unique or unforeseen circumstances. So that we have taken into consideration. So nevertheless, an automatic timetable generators evolves, incorporating advancements such as predictive analytics and machine learning. These limitations are likely to be mitigated, so further enhancing their usefulness across diverse domains. Automated timetable generators will help in the future, not just in schools, but also in hospitals and transportation and colleges. So they are generally getting better at making schedules by considering things like how well students are doing and what teachers like. So these systems can adapt in real time, handling changes like when a teacher is absent or there are changes in students' numbers. So beyond schools, they might be used in hospitals and universities for patient appointments and staff schedules, and in transportation for better routes and planning. Sharing data using the internet, that is cloud computing, could make these systems more accessible, and they could also help with things like assigning rooms. So plus, if we use cool technologies like virtual reality, students might be able to see and interact with their schedules in a fun way. So these timetable generators are getting smarter and might be really helpful in lots of different areas in the future. So these were our few conclusions, findings. And again, we have prepared one questionnaire. So we asked a few questions.
Yeah, okay.
Yes, sir.
Yeah, okay. You are using a nice timetable model because you
Yes,
are
sir.
using different meta-heuristic algorithms to predict your all the resources
Yes,
from
sir.
the student point of views and faculty point of views, all the things. So my question, what is your uh, fitness function?
Fitness function. Sir,
Your
basically,
model fitness function, or it is, yeah.
uh,
What is the
mm,
cost function or fitness function your model?
okay. Sir, the methodology used in this application enables, us to approach evolutionary algorithms. We have used as a basis. So evolutionary algorithms are a class of direct probabilistic search and optimization algorithms gleaned from the model of organic evolution. So a
No. For your timetable model,
yeah,
I'm saying the exactly what is the cost function or fitness function,
okay.
because that fitness function will be calculate and predict your model performance and accuracy based on that fitness function or cost function or loss function. It is calculate because you are using a particular fitness function. So can you say exactly what is that fitness function you are using?
Yes, sir. Fitness function. So, we have actually used OptiSchedule, genetic algorithm, simulated annealing, taboo search, particle swarm, and hill climbing, ant colony optimization. So these were basically used, and the function which you are asking, sir, I'll just yeah. We
No,
have
these are the
used
different meta-heuristic algorithm you are using for comparing the for your
no,
model performance.
yes, sir.
Because
So, yeah.
you are generate a model, that model is based on your fitness function. Because your
Yes, sir.
fitness function passes different input output, after that your model will be trained. That is my question is exactly that is
Yes,
your
sir.
fitness
Sir,
function.
yeah, I can tell this like we have applied penalty to the fitness function. The penalty for the overlapping class would be -10. So update fitness score was subtract the penalty from the overall fitness score of the timetable. So new fitness score was calculated using old fitness score less penalty. This we have written here.
Yeah, correct. Okay.
Yes.
You are
Yes.
using different meta-heuristic algorithm. Which meta-heuristic algorithm gives the best accuracy?
Meta heuristic algorithms.
You are
Uh,
using different annealing method, then other
yes.
method. You are using so many methods. Out of all methods, which method gives the better accuracy?
Sir, that was genetic algorithm which I found, and simulated annealing. So this gave best results. while doing the analysis, according to me. Opti-schedule algorithms. Yes, sir. Yeah, that's all from our side.
Okay, thank you. Please
Thank you
stop your
for listening.
presentation and next presenter, please.
Yeah, thank you, sir.
So next we have Vikas, paper titled Reference Design of D-App Enable Vulnerability Detection as a Service in 6G O-RAN Networks.
Yeah, hello sir.
Ah.
Is it audible?
Yes, it is audible. You may please start with your presentation.
Yeah, I'm sharing it. Are you able to see my screen?
Yes, it is visible.
Yeah, okay. So, good evening all. I am Vikas Vipalapalli along with Danesh Raj, PhD students from Amrita Vishwavidyapeetham are here. We are presenting our work like under the guidance of Dr. Sheshaya Punekanti. Thank you for giving the opportunity to present our work at SMARTCOM 2026. Today, we are going to talk about how vulnerabilities appear in 6G Open RAN networks. In this talk, we will present a reference design for vulnerability detection for 6G Open RAN networks. As networks are becoming open, AI-driven, app-driven, and highly automated, many vulnerabilities do not appear as clear attacks, but they show up as subtle changes in network behavior. Our work focuses on how vulnerability detection can be treated as a native service within Open RAN application system. These are the contents we have. We are going to talk about what is the problem, like why it is existing, then what we are going to present and how it works. These are the abbreviations we are going to see in slides. So what exactly changes in 6G networks? If we look into, basically the networks are going to become open, then they are going to be AI native, and also they will be highly automated. This completely changes the vulnerabilities that are going to come in future networks. So basically Open RAN plays a key role in this evaluation by enabling disaggregation and application driven control across multiple domains which are supported by XApps, RApps, and distributed analytics. However, the disaggregation and multi-vendor deployments also increase the number of interfaces, components, and stakeholders that are involved within the network. In such kind of environments or in that kind of openness, the security problem is going to change and new vulnerability surfaces are going to emerge. So in this kind of situations, when we go with reactive actually like existing traditional methods, they are not going to be sufficient. So we are going with behavior aware vulnerability detection, which is integrated into ORAN ecosystem. These challenges are already being seen in practice in some of the projects like Six Green, Nancy, and Verge. So when we look at the problem statement, basically traditional networks, if we consider, the attacks are not the attacks are from external sources. But when we move into 6G based networks, the attacks are going to be from internal functions or internal methods itself. So they are going to come because of configuration inaccuracies, sensitive optimization logic, and also app interactions. Configuration inaccuracies, these are very common due to disaggregation and multi-vendor deployment. Even a small misconfiguration can affect control behavior. And XApps and RApps, they contain sensitive optimization logic, which is often driven by AI, which can amplify small errors into long-lasting deviations. Since these XApps and RApps are developed independently, their unexpected interactions can introduce new vulnerabilities that were never seen before. Because the control and data paths are tightly coupled into Open RAN architecture, a vulnerability at one layer can easily propagate into multiple domains and across all layers. This makes the cross-layer behavior-aware detection essential rather than isolated traditional perimeter-based security approaches. So coming to the contribution we are making, first we are trying to propose a standard reference architecture for vulnerability detection as a service. Then we are going to talk about how it is placed within the ORAN application ecosystem. Second, we are going to propose distributed analytics model that brings together network level analytics from all these things. Then finally, we are going to talk about behavior based vulnerability detection cycle that clearly distinguishes persistent vulnerabilities from temporary network changes, which will help us in avoiding false alerts caused by short term fluctuations. In this slide, we can see like what are the threats and at which layers they are coming up. As we can see here, almost all layers we have a possibility for vulnerabilities, and we can also see here like some of these attacks they can actually originate within the network, but they actually bypass traditional perimeter defenses. And since control and data paths are tightly coupled, as we discussed previously, one attack at one layer can actually propagate across all domains. In addition, we can also expect to have AI driven threats that can occur silently across all layers, and they will be violating all protocols which are there to detect in the existing system. Given this cross layer and internal threat model, we now present VDAS, how it is architected into ORAN. We are going to present. Now I pass on the presentation to my colleague Danish to continue with this slide.
I hope I'm audible. So before going on to the architecture, I want to briefly set the context. So modern 5G networks, especially those based on ORAN, operate in a very different threat environment compared to the legacy cellular systems. So attacks no longer appear at a single interface or at a single layer. Instead, compromised devices, fake base stations, virtualization flows, insider behavior, and even AI-driven manipulation generate weak distributed signal across the network. So individually, these signals often look harmless, but when they are observed together across layers, they indicate potential vulnerabilities. Because this is exactly why traditional rule-based security mechanisms struggle. They are siloed and designed to monitor one layer at a time. So what we need instead is a cross-layer analytic-driven vulnerability detection, as my co-author said. So that immediately raises two questions. Where should such detection live, and how should it operate in a modern 5G network architecture? So here in this slide, I'm just saying why ORAN and where the system lives. So let me start by explaining why ORAN matters and how our framework fits into it. So traditional RAN architecture were closed.
Sir, your screen, please make it the full screen mode because it is not visible. It is please short mode it is doing. Please make it the full screen mode.
It's in full screen.
Yes, sir. Yes. Is it fine, sir?
Yeah, correct, sir. Correct. Please continue.
Okay, so in traditional RAN architecture were closed and vendor specific. So this made advanced analytics and especially security analytics extremely difficult. So ORAN was introduced to change this. It disaggregates the RAN into ORU, ODU, and OCU, which is the radio, distributed, and centralized unit, which exposes open interfaces with standardized telemetry and, most importantly, introduce intelligent control points such as near real-time RIC, where analytics-driven applications can run. So in our design, VDAS is deployed to close to the ODU and the OCU. And this placement is deliberate because the RAN is often the first place where subtle signs of attacks or misbehavior appear through the control signal anomalies, scheduling irregularities, or even abnormal traffic patterns. So at the ODU, data enters
you have 1 minute to conclude your presentation.
And M-plane interface using split 7.2. So this is why the first stage of ODU optimization function, which my co-author will explain. And in the next slide, you can take, so the green that one, I'm just going to zoom it and explain it. So which is the analytics engine distributed NWDA. So everything starts with the data collection coordination function, which is the DCCF. In dense 5G and future 6G network, the problem is not lack of data, but too much data. So DCCF decide what to collect from which RAN or core function and at what rate, enforcing policy so analytics does not overload the network or violate the latency constraint. So next is the messaging framing and adaptation function, or MFAF. So in that, telemetry from ORAN and SB is inherently heterogeneous. So MFAF normalizes the formats, aligns the timestamp, and even the adapts the semantics, turning raw telemetry into a consistent form. Because this is what enables a true cross-layer of correlation. So the analytics data repository function, ADRF, acts as a system memory. So in the detection relies on the current observation and also on the rely on the history. So next, at the heart of the pipeline is analytics logic function, or ANLF. This is where vulnerability detection actually happens, and then ANLF correlates the live RAN telemetry with core network behavior and even its historical pattern. So finally, the model training logic function, or MTLF, processes this loop, and it continuously update the model using historical data and feed them back into the analytic logic. So finally the output will be an action with an analytics, not a raw telemetry for the using for the NWDF, SMO, or the RIP. So in summary, the ORAN give an openness and near real-time RAN visibility, but the SBA core gives us a structured analytics ready control plane data. So VDAS bridges this domain through a cross-structured analytical pipeline for enabling the cross-layer vulnerability detection. So because you can continue.
Yeah, so as we can see here, traditionally data optimization focus on improving KPIs such as throughput, latency, or resource utilization, etc. But in VDash, we are not just looking at these KPIs, but we are looking at behavioral features. For example, if we consider a threat plane like infrastructure, wherein DAS or DDoS overload happens, we are not just looking at the KPIs, but we are looking something like sustained rise in CPU usage or queue depth or processing delay. Like that, we can see different behavioral features what we are talking. So instead of reacting to single anomalies, this layer evaluates persistent and temporal trends and cross metric correlations across domains. This is the key step that transforms analytics into vulnerability awareness. In the next slide, we are going to present VDAS detection life cycle. So the process begins with telemetry collections from various locations. Then we are going to have MDAF analytics. Then the next step is like behavioral evaluation through data optimization. Here, deviations are evaluated over time to determine their persistence, stability, and cross-metric correlation. Short-lived fluctuations are filtered out as normal network adoption. When a deviation remains persistent across time windows and propagate across domains, it is inferred as a potential vulnerability rather than a transient anomaly. Finally, vulnerability awareness is exposed to ORAN control and management layers, enabling informed actions such as policy updates and XAP governance or operator interventions. This life cycle ensures that VDAS distinguishes true vulnerabilities from routine network dynamics in highly autonomous ORAN environments. To conclude, we present a reference design for VDAS in 6G ready Open RAN networks. The key contribution is architectural positioning of vulnerability detection as a service within ORAN application ecosystem aligned with emerging 3GPP analytic trends. And in future, we expect to come up with experimental evaluation and closed loop integration with ORAN control and management functions. These are the references, and thank you.
Thank you for the presentation. Sir, do you have any questions?
Yeah, okay. Sir, can you explain that cross-domain propagation, how it is maintained during the vulnerability attack, all the things?
See, basically, as we discussed in this particular slide, for example, slides attack or insider attack, it may start from edge cloud, but it can actually propagate into core network. Basically, in 5G or 6G, lower layers like physical and data link layer, they are not secured. Like some of the messages we are exchanging, we are not exchanging in a secured manner. They are exchanged in plain text. So these kind of attacks can actually start from very basic layer like edge cloud, something like that, but they can propagate to core networks. That's why we are saying like we need to talk about cross domain vulnerabilities.
Yeah, during the analytic engine, you are using some analytic engine. That analytic engine, so there is a analytic logic function and model training logic function. So can you show me, explain how that association will be maintained? That things. Yeah, yeah. This
In
is
this
case.
one,
Yeah.
co-author will add points to this, Ganesh.
Yeah, thank you for the question. So that is a key part of the architecture. Within the analytical engine and especially the analytical logical function, association is made through context-aware correlation rather than direct causal assumption. So the function does not assume that a deviation is observed in one domain immediately implies a vulnerability. Instead, it associates observation based on the context and consistency over time. So telemetric and analytic output from different domains are first aligned using common reference dimensions such as sometimes time window, network slices, or affected control procedure. So this always allows the logic to group observation data related to the same operational context. So basically, once aligned, the function evaluate whether deviation can occur persistently across the domain. For example, I will say a scheduling or a control anomaly at the RAN may be associated with some unusual policy enforcement or some session behavior in the core. So provided both deviation can occur within the time and configuration context. So that is what we meant by the association is behavioral and statistical and not rule based or a signature driven. Hope that answered your questions.
Okay. Thank you for your nice.
Thank you.
So next we have Srishti Manish Prasad, paper title The Impact of Compensation, Recognition, Employer Brand Value and Work Environment on Teacher Retention in Public School of Nagpur.
Good afternoon, everyone. I'm Shriti Manish Prasad. I am working as a school teacher and I'm also a research scholar with DMIHER. So my topic for today is the impact of compensation, recognition, employer brand value, and work environment on teachers' retention in public schools of Nagpur. See, when you see the history of Maharashtra, especially in the education sector between 2001 to 2010, we can witness a growth of institutions, educational institutions, teachers, and students. Despite this big progress, the problem of retaining skilled and motivated teachers has emerged as a very serious challenge. A stable teaching force is required to ensure learning continuity, maintain education quality, and support institutional growth. Now, the worldwide studies have shown that teachers' retention is influenced by many factors, such as compensation, recognition, workload, employers' reputation, and workplace environment. Now, why I am doing this study? Because if I talk about Maharashtra, there is a limited studies done for schools of Maharashtra. If I talk about Nagpur, the available literature on teachers' retention is very insufficient, especially in understanding what drives teachers to remain in or exit schools. Most of the prior research is has been focusing on government school. So, recognizing this gap, the present study will investigate how compensation and other factors influence retention of teachers. Some of the literature reviews, the key findings from A.R. Krishnan, M.H. Trivedi, they say that remuneration facilities, institute image, relationship, work environment, and work recognition are the main elements that influence talent retention. Also, adequate and competitive salaries are essential to employee retention. monetary compensation remains the most critical factor among various rewards. With the noted research of O'Reilly and Bound, recognition and rewards foster goodwill and boost morale among employees. Then, according to the study of Saifuddin and Nasibi, a collaborative and supportive environment increases job satisfaction and productivity. Existing research on teacher retention show a lack of multi-decision making models which are well suited for examining complex organizational issues. Additionally, there is a limited work combining quantitative and qualitative dimensions or using systematic evidence-based tools to guide policy. The underuse of analytical techniques such as RANCOM, entropy, and WASPAS further restrict the development of robust data-driven strategies for teacher retention. So I have formulated two objectives, and based on that, there are two hypotheses made. The first objective is to analyze the impact of compensation, reward, and recognition on teachers' retention in public schools. And number two, to assess the role of employer brand value and work environment in attracting and retaining teachers. So these two hypotheses are: number one, compensation, reward, and recognition do not significantly influence teacher satisfaction and retention, and employer brand value and work environment have no significant relationship with teachers' retention. For the research work, multilinear collisional technique was adopted, and data is collected from 100 teachers. Data were collected using structured questionnaire based on 5-point Likert scale, and participants were selected through simple random sample to ensure fairness and representativeness of all the teachers. Then, to test the proposed hypothesis, multilinear regression analysis was applied where dependent variables and like compensation, reward, recognition, employer brand, and work environment were taken as independent variable. The analysis was designed to determine how strongly and in what ways these factors collectively and individually affect teachers' decision to remain in their current schools. Now, this is the interpretation of result. A strong R square value of 0.881 indicates the independent variables are a strong model fit, and there is a high level of statistical significance for the overall model. Then the results of various factors. First, we will take salary and benefit. And very surprisingly, salary and benefit have a significant but negative impact on retention. Then recognition programs have a strong positive and high significant effect on teachers' retention. Come to the third one, school brand. Employer brand value showed no significant relationship with teachers' retention, whereas working conditions have a significant positive impact on teachers' retention. Now, if I integrate one by one, first salary and benefit, we will see that salary is a motivator, but not always. There can be many other factors which are there present directly and indirectly, which shows that retentions are not only combined with the salary thing. This may reflect teachers' perception that primary motivators can be many other factors. Sorry. Recognition emerges as the strongest positive predictor for teachers' retention. Teachers who felt appreciated, acknowledged, and rewarded for their contributions are significantly more likely to remain in the school. Employer brand value or the school's reputation did not show a significant impact. This suggests that while school reputation might influence initial employment decisions, once they are there in the school, it does not play a major role in long-term retention. Then favorable work environment positively impacted teachers' retention. teachers who perceived supportive infrastructures, manageable workload, and cooperative colleagues were most likely highlight the importance of organizational environment. Now, implications of my research work can help policymakers and school administration to prioritize recognition program and support the working condition. Salary structure must be fair, but investment in teachers' morale and workplace culture are likely to yield better retention outcomes. Branding strategies are good, but not sufficient enough alone to maintain teachers' loyalty in public schools. And this is the conclusion that the regression model exhibits strong explanatory capacity, signifying that the selected variables collectively account for a substantial portion of the variance in teachers' retention. These are the references posted here. That's all from my side. Thank you.
Thank you for your presentation. Sir, do you have any
Yeah,
questions?
okay. One question. Yeah, you are using some hypothesis testing by using different
Yes,
predictors. Using different
yes,
predictors, you are conducting that hypothesis testing. So,
yes.
how the p-value will be calculated? How it is correlated with the decisions?
See, first of all, I adopted a multilinear regression model. Now, what is this
Okay.
model? This model talk about several dependent and independent factors where I have taken a test using beta coefficient. Now, what is this beta coefficient? This shows how much one variable is affected by the other variable, how much movement is there. So if I talk about p-value, it should be if it is less than small p-value 0.05 से less है. It means in that case we can reject the null hypothesis, or iska reverse, if p-value is more than 0.05, then we can accept the null hypothesis. So this was being done using the R-square technique.
How it is reflect for the school brand and also working condition, culture condition for that model predictions.
Okay. If I talk about brand value, see, before we enter into any school for interview, then only we decide in our mind we want to be a part of this school or not. So brand images come first. Once you are the part of the school, once the acquisition is done, once you are a part of the program, the interview and your final things are done, now the brand makes little sense. What matters a lot is that how you're working with whom, your colleagues are supportive or not, your leaders are supportive or not. That work culture, that work environment matters a lot. तो वो ज्यादा सिग्निफिकेंट फैक्टर दिखाई देने लगता है, और ब्रांड इमेजेस एक पॉइंट के बाद दे बिकम लेस सिग्निफिकेंट.
So you are using the multiple regression model.
Yes, sir.
So in multiple regression model, you are taking all the input features for predicting your model for hypothesis, or you are selecting the some features and then you train your models.
See, when the questionnaire was made, each questionnaire was signifying one particular factor, variable factor. So here, every aspect was taken separately. When I was focusing on 4 factors, I taken the 4 factors separately, and the separate analysis was done for each one of them.
Okay, thank you for your nice presentation.
Thank you, sir.
I sincerely thanks our author for their excellent presentation and contribution in this session, and all our participants for being a part of this international conference. I hope this session was informative enough. We, on behalf of our whole team, thank you for the support during this 10th version and all the previous 9th version of the conference. We are happy to have you in the 11th version in 2027. All the participants would be getting their digital certificate through email within the 2 working days. The publication will be live within a 7 to 8 month. Kindly cooperate with the team of SmartCom 2026. I also thanks our session chair, Dr. Saroja Kumar, for chairing this session. A token of appreciation to the chair on behalf of Team SmartCom 2026, a global knowledge research foundation and partners. Thank you for your valuable presence. Sir, would you like to give a quick closing remark for us?
Okay, it was an honor to serve as a session chair at SmartCon 2026. I sincerely thanks the organizing committee for their trust and excellent coordination for this event conducting. And also, I appreciate the authors for a different high quality presentation and research work. And at last, the SmartCon 2026 provide a vibrant environment and platform. So where the different researchers are presenting their innovative research work. Once again, I will thank you, the organizing committee.
Okay. I kindly request all the participants to switch on their cameras for a quick snapshot. Thank you. Stay safe. Have a nice day.